I'm Anil Kumar sharing with you a test paper on trigonometric functions. We'll have 18 questions in this test paper. We'll begin with simple knowledge-based questions, then take up communication, application and thinking questions. And I hope that will give you good review on this particular unit of periodic trigonometric functions. Question number 1. The exact radian measure for an angle of 225 degree is. Now to convert angles from degree to radian, what should you do? So we have 225 degrees. We want radians. So radian is pi radians divided by 180 degrees, right? So that gives you the answer. You can always use the calculator to find. So we have 225 divided by 180. That gives you 5 over 4. So the answer is 5 over 4 pi. Right? Now radian is a ratio. You need not write radian. Okay. Question number 2. The exact degree measure of 4 pi by 5 is. Now pi should be replaced by 180 degrees to get the answer in degrees, right? So, or you could do like this, 4 over 5 pi times 180 degrees divided by pi, correct? So pi and pi will cancel out and you can again use your calculator to calculate. So 4 times 180 divided by 5 gives you the value as 144 degrees. Now for some students, sometimes the restriction may be that it is without calculator, right? So at present, we are doing with calculator, but try to do them without calculator also. Question number 3. Starting on the positive x-axis and moving 1/3 of the way around a circle that has a radius of 3 meters, distance traveled will be how much? So basically what we are given here is, for question number 3, you can see that is kind of like this. When we say 1/3, then what is the angle? And we need to measure the angle in radians. So total angle is 360. 1/3 will be 120 degrees, right? So that is the angle. But you have to write angle in radians to get the correct answer. In radians it is simpler, because now the angle is 2 pi is full angle divided by 3. So that becomes theta, right? Now, starting on the positive x-axis, moving 1/3 of the way, that means angle theta is 2 pi by 3, 1/3 of the way. And we are given radius as 3 meters. You need to find distance traveled. That means this distance, arc length. And we know arc length is r times theta, and therefore it should be 2 pi by 3 times 3. So 3 and 3 cancels and we get 2 pi meters as our answer, which is 3.14 times 2, 6.28 meters, correct? Okay. The exact value of cot pi by 6 is what? Now you can actually sketch a special triangle to get the answer. Pi by 6, pi by 3 triangle, right? So this angle here is pi by 3, that is pi by 6. Sides are 1, 2 square root 3, right? Now what is cot? Cot is reciprocal of tan, right? It is 3 over, adjacent side over the opposite side, so it is equals to square root of 3. Is that clear? So from the triangle. So I hope that is very simple and straightforward. Let's move out to question number 5 to 8. You can always pause the video, copy these questions, try them out, and then do, right? Solution of tan x equals to -1 within this interval, minus pi to plus pi is what? So I'm using this area to kind of explain. You know the rule, that is all trigonometric ratios are positive in quadrant 1, sine is positive in quadrant 2, tan in 3, and cosine is positive in 4th. When we are looking into -1, that means either we are in quadrant 2 or in quadrant 4, correct? Within the interval minus pi to pi, so that could be one angle, correct? This is within minus pi, and we know tan is 1 for pi by 4, right? So pi by 4. So one of the answer is minus pi by 4, correct? The other angle which is less than pi will be here. So we have 1 pi by 4, 2 pi by 4, 3 pi by 4. So the other angle is 3 pi by 4. Does it make sense? So that is how you could easily answer it. Question number 6. Equivalent ratio for sine x plus 3 pi by 2 is what? Now let's look into this also. When we say equivalent ratios, we are now looking into co-function identity. Okay, so we are looking for co-function. We know definitely whenever it is 3 pi by 2 or pi by 2 plus something, sine will change to cosine, right? Only thing you have to look for is sine, whether it is positive or negative. So 3 pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2. So the triangle is kind of here. Do you see that? Now here sine is negative. Since sine is negative, as you can see, it should be equal to negative cos of x, right? So that is what it is going to be. If tan alpha or a equals to 0, then cot a is equal to, we know cot a is 1 over tan a, right? So it is 1 over 0, so it is undefined, right? So at this point where tan is 0, we are going to have a vertical undefined, vertical asymptote, right, on the graph of cot A. So you do expect a vertical asymptote here. So these questions help you to review the concepts. Question number 8 is, period for the function 6 sine 5x minus 3 plus 4 is what? Now this is k value, 5, that gives you the period. So time period t is 2 pi by divided by 5. So that is your period, correct? So I hope that's absolutely clear. Question number 9. Equation for a cosine function with maximum at 2, 4 and minimum at 14 minus 2 can be. So let's try to sketch this and then we'll write down the equation. So what we are given here is that there is a maximum at, so let me just draw these dotted lines to help me. This is at 4 and then at minus 2. Let's say this is at minus 2. We have minimum somewhere, right? So the equation is, let's say the graph is kind of like this. Okay. Now what is given to us is that this point here is at 2, x value of 2, maximum at 4, and the minimum at this point is at x equals to 14. This is x equals to 14. And the minimum value is minus 2. So we are given maximum, which is 4. We are given minimum, which is minus 2. So the axis will be right in the center of these two. You add them, that is to say maximum plus minimum divided by 2, which is 4 plus minus 2 divided by 2. So that gives you 1, right? So the axis is at 1. So somewhere here we'll have an axis at 1. Now time period will give us the value of k. Time period is difference between these two, maximum and minimum time, but this is half wave, so it will be twice difference between these two, twice 14 minus 2, which is 24. Now that gives us the value for k, which is 2 pi by 24, right? 2 pi by t, and that is pi by 12. So that becomes the value of k. Now cosine function maximum is at 2, so there is a phase shift of 2 to right. right? Now what is the amplitude? Amplitude A is equal to difference of maximum minimum divided by 2. So it is 4 minus 2 divided by 2, that is 6 over 2, which is 3. One way is this. The other way is we could also find this distance from here to here, which is 4 minus 1, which is 3. Is it okay? Now these things give us the equation. So we can now very easily write down the equation as y equals to, in the form of A cos of k x minus phase shift plus q, which is the axis. So the equation is y equals to amplitude of 3 cos k value is pi by 12, x phase shift is by 2 units to the right, and the axis has moved 1 unit up. Correct? So that becomes the equation for the given situation. So I hope the concepts are clear, and that is how you can get equation for any graph, sinusoidal function, right? Here is question number 10. The height h in meters above the ground for a car as a Ferris wheel rotates can be modeled by the function 16 cos pi t over 120 plus 18, where t is time in seconds. So we have two parts to this question, A and B. A is what is the maximum height of the car? When will it reach the height of 10 meters? So part A, maximum height will be axis plus amplitude. Is it okay? And that gives you the value as 18 plus 16, which is 34 meters, correct? And part B is, when will it reach the height of 10 meters? So you can think this is like, this is your function, right? So we have height is given to us as 16 cos of pi t over 120 plus 18. Now when we have to find t when the height is 10 meters, replace this by 10, 16 cos of pi t over 120 plus 18. So bring it to this side. So we get 10 minus 18 equals to 16 cos of pi t over 120. Now that is equal to minus 8. Let's move on to the right side. I have less space here. Okay. So minus 8 divided by 16, minus 8 divided by 16 equals to cos of pi t over 120, right? Now that is equal to minus half. So in the sine wave, cosine wave, we are getting negative. Negative means we are actually trying to figure out the answer, which is in quadrant 2, right? In quadrant 2. So for what value do you get cos as half? You can use a calculator, or you could use special triangle. So special triangle can work for half. We know for pi by 3, cos is half, right? So this value should be pi by 3 alpha. So this is like alpha equals to pi by 3. So we actually calculate the alpha. But now the angle has to be in quadrant 2 since it is negative half, right? So that is the angle where the acute angle is pi by 3. So this is 2 pi by 3. So I hope that concept is clear. So that happens when the angle theta is 2 pi by 3. Perfect. So we can now find time. So we have this equation. We can write this as pi t over 120 equals to 2 pi by 3. You could simplify this. Pi and pi cancels. And that gives you the time t as equal to 2 times 120 divided by 3, correct? So that goes 40 times 2 as 80, right? So you could divide this 40 times 2. So we have t equals to 40 times 2 as 80, and it is in seconds, right? So you could say 1 minute and 20 seconds. as your answer, correct? So that is how you could solve this question. I hope the steps are absolutely clear. Feel free to put remarks or comments if there is a doubt, right? Let's move on and take up the next question, which is on sketching trigonometric functions. Question number 11, sketch trigonometric function y equals to sine 2x and its reciprocal. Explain key features of each graph and list their similarities and differences. So that's a communication question. It is mainly to review the concepts of trigonometric functions graph and their reciprocals, right? So what you can do is, now it's kind of an open question. We are not even given any domain for this. So let me just sketch a graph of a sine function saying like this. Okay, so I'm just sketching sine function. I've taken the value as y equals to sine 2x. That means that the time period should be how much? Time period will be 2 pi by 2, which is pi. So this particular wave, which starts at 0, one wave is completed in pi radians, right? So that becomes x for us, and this is y. Now, so that becomes the function. We can write it in green. This function is sine 2x. Now, okay, so let's label this. This is pi by 2, and this is pi by 4. You'll actually get a good graph paper to draw this. So 1 pi by 4, 2 pi by 4, 3 pi by 4, okay. So I'm just sketching one wave here. You could go on this negative side also, minus pi by 4 and minus pi by 2, and so on, correct. No harm in taking one more wave here, right? So, okay, let's do it like this. So we'll just kind of terminate it here, where this is going to be, okay, so the whole cycle is 1 pi, so minus pi, is it okay? I wrote something wrong here. Minus pi by 2 is half, and this is quarter. 3 pi by minus 3 pi by 4. Okay, now it's okay. So this value here, amplitude is 1 minus 1. So that is the sine 2x function. To sketch the reciprocal, all the zeros will become vertical asymptotes for reciprocal, correct? So these are your vertical asymptotes. So first sketch the vertical asymptotes. That is how you're going to sketch the reciprocal functions, correct? So these are your vertical asymptotes. So the graph reciprocal r of x is 1 over sine 2x, which you can write as cosecant 2x, correct? So that is the graph which we are sketching. So this particular graph, reciprocal of 1 is 1, so it will look like this. It will be looking like this, is okay? So it's kind of like this. So you can do more accurate graph, but once you are working on a graph paper, but that is how the reciprocal function will look like, with vertical asymptotes at pi by 2's, right, as shown here, pi by 2's multiples, and one value at pi by 4, their multiples, and negative 1 also at minus pi by 4, right? That is how you're going to get your particular graph. Okay. Now, what you notice here, similarities. Now, as far as the similarities are concerned, you can notice that now we have to explain key features and their similarities and differences. Now, the critical part which I want to highlight is how to discuss similarities between these graphs, right? So let's talk about similarities. Now, there are a lot of differences which you can always write. Similarities, we can say that they have turning point at the same point. You see that? Turning points are at pi by 4, and also 3 pi by 4, odd multiples of pi by 4. So we have turning points. At odd multiples of pi by 4, that is 2n plus 1, will give us odd multiple of pi by 4. Does make sense to you, right? So that could be one similarity. The other similarity which is related to this particular point is that the tangent at these points is 0, right? So the other is tangent 0 slope, right? So 0 slope tangent is common between these points, correct? So these are good similarities to mention. Is it okay? Now when you sketch this graph, you can see the x-intercepts for now differences. Major will be x-intercept of the function y equals to sine 2x is actually vertical asymptote for cosecant 2x. Do you see that? That's a major difference. The x-intercepts are at which points? They are on the multiples of pi by 2, right? So 1 pi by 2, 2 pi by 2, 3 pi by 2, or so on. So these are at x equals to n pi by 2. So those are the points where the x-intercepts become vertical asymptotes. The other difference could be in domain and range, right? So differences, we can also look into domain and range. As you see, the sine function is continuous without any breaks, whereas we have vertical asymptotes, and therefore the domain of the function does not include the n pi by 2's, right? So n pi by 2 is not there for cosecant 2x. As far as the range is concerned, range for sine function is between, so range for this function is between -1 to 1, and the range for this function is always either it is less than -1 or it is greater than equal to 1, correct? So domain and range are different. So I hope that makes sense. So the vertical asymptotes are not in the domain of the reciprocal function, right? So that gives the restrictions in the domain. And these vertical asymptotes are at, we just mentioned here, the x-intercepts of the sine function, which is n pi by 2, right? So n pi by 2. So these are not in the domain of cosecant x. So for cosecant, cosecant x 2x, I should write 2x, the domain of the function is x belongs to real numbers where x is not equal to n pi by 2, right? Where n belongs to integers, okay. So I'm using n as integers. N belongs to set of integers, right? So I hope in short that gives you the gist of the answer. But I like you to explore such questions and understand how to write at length the similarities and differences between the trigonometric function and their reciprocals. I hope that helps. Let's move on to question number 12. Question number 12. Make an equation to describe the motion of a point on a wheel that has center 4 meters off the ground, has a radius of 15 centimeters, makes full rotation every 10 seconds, and starts at the lowest point. Now from the given information, let me sketch a graph and then we will try to figure out the equation. So as we can see from here, the wheel has a center 4 meters off the ground. So let's say this is 4 meters off the ground. Okay, so this is 4 meters. Has a radius of 15 centimeters. Okay, 15 centimeters. The units have changed. 15 centimeters, right? So, okay, so that's funny. Okay, so let's say this is 4 meters. That really means if you write in meters, then it is going to be 400 centimeters, right? So let me write this as 400 now. We are writing in centimeters. Okay. Now 15 is a very small value, but think like this. Radius of 15, let's make it not to the scale. Let's break this scale from here. Does make sense? Okay. So what I'll do here is that the maximum will go 15 centimeters above and 15 below. Is it okay? Right. Now it says starts at the lowest point. So let me start at the lowest point and then make a wave first. Okay. So that is how it is. So the maximum value will be 415 all in centimeters, and the lowest will be 15 less than 400, so 385, right? 385. Now it says that make an equation of this, describe the motion of the wheel. 4 at the center, has a radius of 15, full rotation every 10 seconds. So this is one full rotation in 10 seconds, right? So we know the time period t is 10 seconds, and therefore the value of k is 2 pi by 10 or pi by 5. Is it okay? So that becomes the value of k. Since we are starting at the minimum, we are going to use the equation in cosine function, right? So we have to write the height. Let's say this is the height above the ground with time t. This is time t in seconds, right? So we can say height above the ground is equal to, the amplitude is equal to the radius, which is 15 centimeters. So we'll write 15 cos of, now since it is starting with the negative, I will write negative here, right? So minimum minus 15 cos. So we have taken care of phase shift. K is pi by 5, so we get pi by 5 t, and the axis is 400, so we can write this as 400. So that becomes your equation, right? So I hope that is absolutely clear. Okay. Now, so go through it once again, try to understand how we can give this equation, where we have given height in centimeters and time t in seconds. Okay, so that is how we are going to write the equation. Okay, so let's move on to question number 13. Question number 13 is, a roller coaster at a theme park starts with a vertical drop that leads into two pairs of identical valley and hills as shown. Explain at what x value the graph starts to exhibit the sine function. Write the equation of a sinusoidal function to model that part of the graph. So if you look at the graph here, what do you notice? We notice that the sine function is something periodic which repeats. It repeats from this point, right? So that is one wave, and then we have the second wave. Correct? So that is the point at t, at x equals to 2, it becomes a sine function. So let me highlight this. Okay, so this is the point which we are talking about. Okay, now since it repeats, we know these are the two waves. Now explain at what x value the graph starts to exhibit, that is what it is. Write the equation of a sine function to model that part. Okay, so from here we know the axis is at 4. So we know the axis is at 4. Maximum is 6, minimum is the value 2, and the time period t is from here to here, one wave, right? So 6 minus 2, which is 4, and therefore we can now write this as minus, because it starts from the beginning, I mean going downwards. So we could write this function as y equals to minus sine as it goes down first. So we have taken care of the phase shift. K value will be 2 pi by t, which is 2 pi by 4, or is equals to pi by 2. Is it okay? So that becomes the k value. So the sine of pi by 2. Now this negative sign has actually is from 2 units to the right. So that much x is our variable, right? So x minus 2. And the x is 4. So this is one way of writing this equation. Is it okay? Since it starts from here, right? Not before this. So that is how you could actually write your function as a sine function. Is it okay? So that will be the equation for this particular graph. So I hope that is absolutely clear. Feel free to make your suggestions on this particular question. So don't go before this, okay? So minus sine, so it goes down first. One wave is in 4 seconds time period, right? Time period 4. So k value is 2 pi by 4, which is pi by 2, right? That is the k value. Phase shift, since it happens at x equals to 2, so towards the right, minus 2, and 4 is the axis. Perfect. So let's move on to question number 14. Question number 14. Determine the average rate of change of the function 15 cos pi by 8x plus 1 from x equals to 8 to x equals to 18. Express as an exact answer and as an approximate answer to 2 decimal places. So rate of change, average rate of change is f, the variable is x here, so f of x2 minus f of x1 divided by x2 minus x1, right? So that is the average rate of change, right? So we can say average rate of change for a given function. So let's find what is f of x2. We'll write this as x1 and x2, right? From and to. So basically x2 is 18. So let's find what is f of x2 equals to, which is f of 18, right? So if I replace this with 18, x with 18, we get 15 cos 18 over 8x plus 1, and that gives you 15 cos. Now both could be divided by 2, so get 9x by 4 plus 1. So pi by so the x value, I'm sorry, it should have been pi. I'm writing x. I replaced x with 18, so it is 18 pi. Okay, right. So pi by 4. We are saying 9 pi by 4. So where is 9 pi by 4? 9 pi by 4 means 1 full circle, and then you're back to quadrant 1, right? So 9 pi by 4 means you're back to quadrant 1. And for pi by 4, cos function is 1 over square root 2. So you can have a special triangle where for the pi by 4, the sides are 1 square root 2, correct? So you could write this value as 15 times 1 over square root 2 plus 1. So that becomes x2. Now let's find out what is f of x1, which is f of 8. So if I replace it with 8, I get 15 cos 8 over 8 pi plus 1, which is pi, right? So cos of pi is how much? Well, at times you could just sketch the cos function, right? So cos function basically starts with a maximum, ends with a maximum, and at pi it is minus 1. So this portion is minus 1. So you get minus 15 plus 1 as this value, correct? Minus 15 plus 1. Purposely, I'm not really doing it because rate of change will take away and cancel out, right? So now we can actually find the rate of change. So average rate of change is equal to f of 18, which is this function, which is 15 over square root 2 plus 1, minus f of 8, which is this function, which is minus 15 plus 1, divided by 18 minus 8, right? So divided by 18 minus 8. So that gives you 1 and 1 cancel. And here minus minus becomes positive, right? So we could take this as 1 over square root 2 as a common factor. So we get 15 plus 15 square root 2, right? And the denominator here is 10. So that becomes the denominator. You can factor out 15 now. You can factor out 15. So we get 15 over 10 square root 2. And within bracket, you get 1 plus square root 2. This can be simplified. Dividing by 5, we have 3 over 2 square root 2 times 1 plus square root 2. Now, it's a normal practice to rationalize, correct? So, to rationalize, whatever we are going to multiply and divide by square root 2. That is how we'll rationalize. Is that okay? So, I could write this answer as equals to 3 over 2 times square root 2 in the denominator, and we have 1 plus square root 2. Now we'll multiply and divide by square root 2, correct? So that becomes 2 times, right, times 2 in the denominator will give us 4. So we get 3 over 4 here. Multiplying numerator by square root 2 gives us square root 2 plus 2. Is that clear to you? So that is what you are going to get in the numerator, correct? So that is the numerator, which you could always write as 3 square root 2 plus 6 divided by 4. So that becomes the exact value. Now to find the decimal place, we'll use the calculator. So we have 3 times square root 2 equals 2, and we'll add 6 to it, and then we'll divide by 4, and then check the decimal value. So the decimal value here is equal to 2.560. Since we have to round it to 2 decimal places, I could write this as 2.56, and the units are, well, they're not given any units here, so we'll just leave it like this. Perfect. So the answer to 2 decimal places right there, and the exact value is this, correct? So I hope it makes sense. And I hope that's a good revision on your rate of change in this particular unit for sinusoidal functions.